Hello, welcome to this live technical discussion series. And today we are going to talk about draft standards of IS 1893 Part 1 and Part 2. So there are significant changes which are proposed in the recent draft which are published by BIS Technical Committee. And while going through the document, we could realize that it will require very detailed discussions. So with this, we are planning actually number of live sessions for this draft standard. So this is first of such session which is planned today. And with the registration form, we have received very interesting discussion points. It is reaching around 350 plus points. But what we decided that firstly, let's have quick view of IS 1893 Part 1 and Part 2. And thereafter, we'll be getting into more detailed discussion of individual queries. So in today's discussion, we will be having quick view of IS 1893 Part 1. Okay. Okay. Yes, welcome Olav, welcome Rajnikant, welcome Divas. So you all will be able to interact with us through the live chat, and at present the session is live on LinkedIn, YouTube, and Facebook. But the stream will be more stable on YouTube. So just let me flash the YouTube channel, so you can see this the YouTube channel link, which is scrolling at bottom of the screen. And as we discussed that we will be having number of sessions on this important point, right? So the next session will be planned maybe within let's say a week of time, or let's say even earlier than that. So this is the link which is scrolling at the bottom of the screen, which is sqvconsultants.com/register. So you can register on this link, and then with this you will receive information from our site. So with this, now let's get started, and let's have a quick view of IS 1893 Part 1. Okay. Okay, so let's begin this session now. Let me share the screen. Okay, I hope you are able to see the screen now. So this is IS 1893 Part 1. And this IS 1893 Part 1 is the general document which will be applicable to the other parts of the document. So with this, our present IS 1893 Part 1 is now shifted as IS 1893 Part 2. So this Part 1 is completely a new document, and there are very important points which are mentioned. So let us have very quick view about important changes which are proposed in this standard. Okay. Yeah, just let me set it right. Okay. So the last date for comment is 25th of June, and that's why we will be arranging a number of discussions on this standards in the near future. Okay, so this is the first very important part, like, and it is said that kindly examine the attached draft and forward your views, stating any difficulties which you are likely to experience in your business or profession if this is finally adopted as a national standard. So with this, we have an opportunity to review these documents critically, and wherever we find that there is a possibility of practical difficulties, we must write with our comments to BIS technical committee so that they can take appropriate actions. Okay. And this is the general format which is always attached with the technical documents or draft standards. So we can always send the clause number, comment suggestions, modified wordings of the clause, and this last column is very important, wherein we can suggest the reasons for or we can say justifications for the proposed changes. So according to me, this column will be very helpful for the technical committee for taking the decision while making the modifications. So we should detail out our reasons or justifications related to the proposed changes. Okay. Okay, so as it is said in this document that about 59%. So firstly, always we start with the forward of the document. And here it is said that about 59% of India's land area is prone to moderate to strong earthquake shaking intensities. Right. So with this, the earthquake zone map, which is in fact earthquake zone map is now revised in this standard, as we all know, is a reflection of the relative peak ground accelerations likely across the landmass of India. Now, here it is making one more statement that safety of people in a structure during earthquake depends on two factors mainly. So one is the structural elements, and another is the non-structural elements. So for the non-structural elements, a detailed section is now added in this standard. So specifically for the non-structural elements, what is mentioned here that the damages or we can say the failures can have major social or economic implications, particularly in critical buildings and structures. For example, schools and hospitals, which are critical buildings, and also in the commercial buildings like stock exchanges, for example. In this entire document, the non-structural elements is referred as architectural elements and utilities with the short form AEU of a buildings or structure, and that shall comply with all applicable relevant existing national standards and guidelines laid down by the various statutory or let's say non-statutory bodies. So here it highlights in this paragraph that whatever the changes which were proposed in the earlier version, which was 2016 version, all changes are highlighted here. Okay, and it says in 2023, The committee decided to present the provisions for different types of structures in separate parts to keep abreast with the rapid developments and extensive research carried out in earthquake resistant design of various structures. So with this, we can see there are total 11 parts, including this part 1 to part 11. There are 11 parts, and there are number of parts which are to be formulated yet, which is under formulation, we can say. So the part 1 contains the general provisions on earthquake hazard, which is applicable to all structures. So part 1, what we will be discussing today, we'll be having a quick view of the part 1, which will be applicable to all these structures, or rather it is applicable to all the parts, which is part number 2 to part number 11. Okay. Unless stated otherwise. The provisions in part 2 to part 11 of 1893 shall be read necessarily in conjunction with the general provisions as laid down in this standard. Now, it is also there said that thus a parallel series of standards will be also formulated as earthquake resistant design and detailing of structures, which is IS 13920 part number 1 to part number 11. And similarly, earthquake safety assessment and retrofitting of structures under IS 13935 parts 1 to 11. So with this, we can say that many more standards are getting formulated, and number of significant revisions will come in the near future as and when these parts will be published. In this seventh revision, the major revisions which are mentioned in the forward part. So firstly, the revised earthquake zone map based on probabilistic earthquake hazard assessment has been introduced. Secondly, design horizontal acceleration coefficient. Now they are specified for strength and serviceability designs for each earthquake zone. So for strength and serviceability design, it is proposed to have different coefficient. Then acceleration response spectra has been now defined up to natural period of 10 seconds. Then a method has been provided for estimating soil flexibility. And the method for estimating liquefaction potential at a site has been revised. So this is briefly described here as following major changes in this document. And as it is mentioned in this document, probabilistic seismic hazard map, which is PSHM, was already prepared by NDMA in 2010. And the probabilistic earthquake hazard map, which is PEHM, which is introduced in this standard, is based on further research work done at IIT Madras, based on the financial assistance from NDMA. Okay. So the background about the development of probabilistic earthquake hazard assessment, it is included in the Annexure G of this document. Okay. And these are several standards which are referred while preparing this document, like IBC 21, NEHRP, then FEMA P2082, ASC standard, New Zealand standard, IS 16700, NDMA, FE, FEMA, etc. Okay, so this is part 1, general provision. So what we'll be doing in this session, we will have a quick glance through this entire document, so that you can also catch up certain finer points, and then for any points wherever we find that there could be practical difficulties, we can write to BIS technical committee in the above mentioned format. So that's the intent of this first session. And please feel free to populate the comment box with as many discussion points as you have, because in the subsequent sessions we'll be having more detailed discussions about each and every clause. We'll also have similarly discussion about part 2. So firstly we will have quick view about part 2, and then we will have discussion about individual section or the clauses as it is coming through the registration form or the points which are mentioned in the comment box. Okay, so please feel free in writing down as many discussion points as you have with reference to this two standard. So right now what we'll be doing in this session, I'll quickly go through this document, and then I'll try to highlight the few of the practical difficulties which I could feel based on my experience while going through this document. So still I am referring this both the document. Still I have not completed my own analysis, but whatever details I have understood as of now, that I'll be presenting now. Okay. So firstly, in any document, the scope is extremely important. So what it says here, that this standard primarily deals with the earthquake hazard and criteria for earthquake resistant design of all structures. As we discussed, it is applicable to all structures. And design earthquake hazard and criteria of earthquake resistant design of buildings and other structures are dealt separately in part 2 to 11, right? So that's okay. Then there is clause for the parking structure, temporary structure, etc. Now here it says in this para number or section number 1.4 that the provisions of this standard are applicable even to the critical and spatial structures like nuclear power plants, petroleum refinery plants, and large dams. So for such structures, additional requirements which may be imposed in the associated statutory authorities of India needs to be considered. But the minimum requirement, whatever is specified in this standard, which is in part 1, should be considered for these important structures as well. Okay. This is one of the major change made in this document. Now, this standard also provides requirements for the design consideration for these AEU elements, which is architectural elements and utilities. So for that, the minimum forces and the displacements are to be considered in the design and construction of the connections of this element based on the details which is given in this standard. And this AEUs or design of AEUs to be considered for the planning and design and construction of AEU in new buildings, or let's say if we are doing replanning, assessment and retrofitting of AEUs in existing buildings. So for both the cases, this standard needs to be referred. Now, this is important point, like the provisions of this standard shall be applicable for the protection of AEUs in the following buildings and structures that are located. Firstly, it is mandatory to consider the design of AEUs in all hospitals and critical buildings. Critical buildings in any earthquake zone, it needs to be considered. And then for buildings and structures whose importance factor as per table number 5 of CED 39-22345, which is for the buildings, is 1.5 or more. So in both these cases, it is mandatory to consider the protection of AEUs as per this design standard. Okay. So what happens if the building is not falling under these categories? So in that case also, it is mentioned here that in all other building and structures also, the provisions of this standard are recommended for the protection of AEUs. Further, the specifications laid down in the standard shall govern over similar requirements given in the prevalent relevant Indian standards. Okay, here it is one more requirement that the provisions of this standard shall not be applicable when the AEU has a mass which is more than 1 percentage of the mass of the whole structure on which it is resting. And second condition, when AEUs at a certain level together have a mass more than 1 percentage of the mass of the whole structure on which they are resting. So as I understand, it's trying to say that whenever the mass of AEU is, let's say, greater than 1 percentage of the total mass of the whole structure, so in that case, this following para needs to be followed. In the above cases, when the AEU has a mass which, if it is more than 1 percentage of the mass of the whole structure on which it is resting, then the AEU shall be included in the structural model of the structure which is used in the design of the structural elements. So here it is not clear to me like how we will consider this in the structural model, like how AEU can be included in the structural model. I think that needs to be detailed out in this paragraph. Okay. So in this document, I'm just quickly sharing my understanding. So if you have different understanding for the particular clause, please mention it in the chat box. Okay. And we'll discuss the same towards the end of the session. And let's say if the time doesn't permit today, then we will discuss the same in the next session. But please feel free to populate the chat box with as many points as you have, so that we don't miss out on any important points while sending our comments to BIS Technical Committee. The terminology section is now expanded. Of course, it's a completely new version, but there are so many new terms which are added as a part of terminology. So first, terminology is added for the architectural elements and utilities. And it is having three mode of failure, we can say, which is rocking, sliding, or let's say toppling. So basically these are mode of failure for the AEUs. So rocking is without sliding or toppling. In a sliding, there will be a movement laterally on the horizontal surface, and toppling, like if it falls off sideward from its supports. So these all terminology are written in context of AEU and utilities. Now, this is a new terminology, bare structure. So buildings or structure without AEUs will be considered as a bare structure in this document. And rest, this is okay, this definitions. Okay, this is one part. The elastic force reduction factor. So earlier we were telling this as a response reduction factor. Now it is mentioned as elastic force reduction factor. So it is nothing but the concept is same as the response reduction factor. So this is the factor by which the base shear induced in a structure, if it were to remain elastic, is reduced to obtain the design base shear. It depends on the perceived earthquake damage performance of the structure, characterized by ductile or brittle deformations, redundancy in the structure, or overstrength inherent in the design process. So basically, this is nothing but response reduction factor what we have in the present standard. Floor response spectrum. So whenever we have equipment which is supported on the structure, so at that time the particular floor or particular joints who could have a different uh, response with reference to applied ground motions. So for equipment design which is sitting on a particular floor, so at that time it is important to derive this floor response spectrum, and then this floor response spectrum needs to be handed over to the equipment manufacturer for further design of the equipment. Okay. So this flow response spectrum, generally this will be applicable for the design of industrial structures. Importance factor is okay. Limit state is okay. Okay, these are few definitions related to structural dynamics. Okay, this is probabilistic earthquake hazard assessment, which is PEHA, which is done in this standard, and it is considering the following aspects like seismotectonics of the region, likely maximum magnitudes of the earthquake on each of the faults in the radius of 300 kilometers around the site, potential fault mechanism and rupture plane characteristics, attenuation of earthquake ground shaking along the path as it reaches the site from the source of the fault rupture, then aleatoric uncertainties related to earthquake events, and then epistemic uncertainties related to mathematical modeling of the considered region. Response history analysis is nothing but time history analysis, as we say. Okay. Response spectrum we know. Okay, and there are a number of new symbols added in this standard because there are new concepts involved. So that's why we could see there are a number of new symbols which are added in this document. Okay. So these are all now general principles for design of the structure for earthquake resistant design. And here in the last para for the ground motions, it says that the predominant direction of ground vibration is horizontal in the far fault region, and the horizontal and vertical shakings are comparable in the near fault region. So whenever structure is located in the near fault region, so at that time vertical and the horizontal shaking both will be comparable. And if it is a far fault site, that means site is located away from the fault region, so in that case obviously horizontal earthquake will be governing region. Okay. And vertical earthquake, as it was mentioned in the previous standard, also will be important for the structures with the large spans and then structures in which stability is the criteria for design. So further reduction in gravity force due to vertical ground motions can be detrimental, particularly in pre-stressed horizontal members or cantilever members and gravity structures. So for all those kind of a structures, special attention needs to be paid for the consideration of effective or effects of vertical ground motion on those kind of structures. And forces for design of structures. So so here it describes the inelastic behaviors in structures, and the inelastic behavior in structure is considered, and the entire concept is included in the structure based on the ductility, right? So ductility arising from inelastic material behavior with the appropriate design and detailing, and then overstrength resulting from the additional reserve strength in the structure over and above the design strength. So these are the two areas by which inelastic behavior in the structure is considered. Okay, so these are the two aspects on which the structural design is relied upon for overcoming the difference between the actual and design lateral loads, because as we know that actual loads could be significantly higher as compared to the design loads. So based on this ductility and overstrength, the gap between the actual and the design loads is overcome, or we can say it's breached. So there are a number of general statements which are made in this part 1. Okay, then the design of ductile response of the structures. So for ductile detailing, IS 13920 needs to be followed, and IS 800 for the steel structures. And as it is mentioned in the earlier forward that in 13920 also we could have different parts for the different types of structures rather. The soil structure interaction is included. So this is one of the practical difficulty. Soil structure interaction refers to the effects of flexibility of supporting soil foundation system on the response of superstructure. It may not be considered in the earthquake analysis of structure supported on the rock or rock-like material. So in the subsequent pages, the definitions are given, like how we'll identify the type of soil, whether it is a rock or rock-like material. But as it is mentioned here, if structure is supported on rock or rock-like material, then soil structure interaction is not required, or it may not be considered for. And one more condition is given, that if the depth of founding is shallow. So in all other conditions, soil structure interaction needs to be considered. The floor response spectrum, we just discussed that for design of equipment and other systems which are supported at various floor levels of a structure, it will be subjected to different motions at their support points. So in such cases, it may be necessary to obtain these floor response spectra for design of equipments, and for details reference may be made to part 5. So part 5 is nothing but earthquake resistant design of industrial structures. Okay, there are certain assumptions made here, that there is no possibility of resonance because earthquake is the transient force. Then it's not likely to occur simultaneously with high wind, etc. Okay, and the values of elastic modulus of materials wherever required will be those for static analysis. So just for your reference, the value of elastic modulus of materials could be different for static and dynamic analysis. So here it's clarifying that we can consider, or rather we should consider, elastic modulus for the static analysis based on these standards, unless more definite values are available for use in the dynamic conditions, right? Okay. So now in the section number 6, it starts with the earthquake hazard. So the earthquake hazard could be in the horizontal direction and vertical shaking. So both the effects are mentioned here. Now, first of all, the earthquake zones. So there are many points, many discussion points we have received for this part or this question. And now earthquake zone is changed in zone number 2, 3, 4, 5, and 6. Okay. So which is given in this figure number 1. Okay. Okay, so this is updated figure number 1 for the zone. And as we can see that now it is going up to zone 6, right? So in this part 1, what it said that the design earthquake peak ground acceleration is now actually dependent upon the categories of the structures. Now, the categories of the structures are derived based on the relative severity of the negative consequences in the event of the failure of a structure, and structure shall be considered for the purposes of design to be 5 categories. So all structures will be divided in 5 categories, like normal structures, important structures, critical and lifeline structures, spatial structures, and nuclear power plant structures. Now here it makes one statement that the sub-classification into set 1, set 2, set 3, and set 4 of each structure type into the above 5 categories are dealt within the corresponding parts of IS 1893. Okay, so I'm here to refer part 2 in conjunction with this statement, but at this point it's not clear to me. Okay. So if you have certain thoughts on this set 1, set 2, set 3, set 4, you can mention it in the chat box. Okay. Okay, now here there is a new concept added for the return period, and what it is said that the earthquake zone factor Z to be used for the above mentioned 5 categories of structures shall be based on the corresponding return period, which is TRP, for strength design and serviceability check. So for the strength design, return period is higher, and for the serviceability check, return period is lower. So lower the return period, the intensity of the earthquake will be lesser, right? And as the return period increases, the earthquake force will increase on the structure. So here table is given where these set are mentioned like set 1, set 2, but it's not clear to me. Okay. But these categories of structures like normal structures, important structures, critical and lifeline structures, etc. So all structures are firstly divided in 5 categories. And for each category, the return period is mentioned for the strength design and serviceability check. Okay. So here we can see for important structures, it is 975. Then for critical and lifeline structures, it is 2475. For spatial structures, it is 4995. And then in this table, the earthquake zone factor for different return periods, TRP, are mentioned for the different earthquake zones. And there are several documents prepared which were shared in the social media related to these calculations. And then it was observed that the earthquake force has increased significantly as compared to the present standard. So here the zone factor Z is identified for all different region periods. Okay. Now in the site class, the site of a project shall be placed under one of the site classes listed in table 3, which are based on the weighted average Vs of the underlying soil strata. So for the purpose of estimating Vs, which is nothing but shear wave velocity of the underlying soil strata as per table 3, the field investigation shall be carried out at least up to depth of 30 meter unless a rock layer is encountered before that. And when shear wave velocities of soil layers, if they are not available, then the corrected SPT values may be used, okay, as it is shown in this equation. So for the purpose of identification of site class, the geotechnical investigation shall be carried out up to the depth of influence below the founding level as specified in the following table, or 30 meter, whichever is larger. So these are this is the table for classification of soil. So wherein we can say type E soil is extremely soft soil, and type A and let's say up to type B we can say it's a rocky or hard strata. And here in this table, it identifies the depth of influence on underlying soil layers to be considered below NGL. So here it is identifying in this table the type of foundation and depth of influence which needs to be considered for different types of foundation like spread footing, mat foundation, pile group, etc. Okay. Okay, and then for this normalized horizontal PSA corresponding to let's say 5 percentage damping of 5 percentage, which is let's say for each site class shall be obtained from ANV 5 percentage TH. So above ground, for a viscous damping ratio of 5 percentage of critical damping, the normalized horizontal PSA for the portion of the structure above ground in the projects constructed on site class A, B, C, and D. So here we can see that class E is not available. So for class E, the spectra is not included, and then it is required that for class E, we need to generate the spectra because E is very, very soft soil. And then for use in linear dynamic method, which is a response spectrum method. So these are the equation. These equations are derived based on the graph which is indicated below. This for use in linear equivalent static method, etc. And this is the graph which is included for normalized horizontal elastic PSA, and which is up to 10 seconds. Okay. So there are a number of points we have received for this calculation. So of course we will talk about this in subsequent session if it is required, because there are already number of documents which were shared in the social media, and then it was worked out that by considering this entire calculation, the earthquake force is increasing significantly. And if the portion of the structure is below ground, then we can reduce the earthquake force coefficient with this equation. It is the concept is in line as with the present standard. So these are all equations given by which we can work out the required values. So the equation for AH is now upgraded like this, which is Z, which is the zone factor we'll get from that table. I is the importance factor, and ANH or ANV. So there are two terms, ANH and ANV. So ANH is for the horizontal PSA, and ANV is for the vertical PSA. So whatever value we get out of this equation, now this needs to be divided by the elastic response reduction factor, or we can say response reduction factor. Okay. So with this we will get the earthquake force which needs to be applied on the structure. Okay, there are calculations for the displacement spectrum as well as for the velocity spectrum, which is included. Okay, and this point we have already discussed, that spectra for site class E is, let's say, no normalized horizontal and vertical PSA. PSV is for the velocity, ST is for the displacement spectra, are provided for site class E. So for such cases, site specific hazard assessment needs to be done. So which is defined in the following section, that how we should carry out the site specific earthquake hazard. So here it defines the brief procedure about finding out the earthquake hazard for the based on this probabilistic earthquake hazard analysis, which is PEHA, which is considered in the present standard. So here it says uniform hazard normalized PSA spectrum shall be derived. Then return period, whatever we adopt for this site specific assessment, then those return period needs to be consistent with that specified in this table 2, which we discussed earlier, based on the category of the structure. Then the basic PSA spectrum shall be derived for 5% of critical damping, and for all other values of damping, the spectrum may be obtained by multiplying with the factor which is defined in the 6.2.4.2. And the earthquake hazard estimated based on the principles of PEHA shall not be less than that is estimated based on the principles of deterministic earthquake hazard analysis. So this point is not clear to me. What is deterministic earthquake hazard analysis? And the elastic maximum horizontal site specific spectra shall be estimated with this value. and vertical site specific spectra with this equation. Okay. Now, this is major revision according to me, or very important provisions added here, which is principles for design of structures. And here it defines performance expectation. So what it says here, that structures designed as per this standard may sustain damage during design, earthquake, ground shaking, and also the provisions of this standard are intended for earthquake resistant design of structures without base isolators or energy dissipation devices built into them. So this standard doesn't consider inclusion of base isolator or energy dissipation devices. So what it says here, that further this standard provides the minimum design force for the earthquake resistant design of spatial structures also, such as large and tall buildings, large and high dams, etc., even for the major industrial projects. So such projects require rigorous site-specific investigation to arrive at more accurate earthquake hazard assessment. And here it says that currently the Indian standards for design of buildings with energy dissipation devices built into them is under formulation. So we expect, or we will may receive these documents also in the future for inclusion of this spatial devices also. Okay, this is important, which is damage. In this standard is intended to design the structures that sustain ductile damage. Okay. To achieve the same, the following shall be ensured in the design of structures. Like, all brittle modes of damage shall be precluded from occurring before the occurrence of the ductile modes. Secondly, it says a predetermined desirable ductile collapse mechanism in the primary structural system shall be considered. And the same needs to be ensured through providing acceptable strength hierarchy between adjoining members and within each member. Then it says the location of damage within horizontal and vertical members shall be such that they permit global ductile response of structures. And for base isolation systems or energy dissipation devices, when used, may alleviate damage in structural elements under the design level, earthquake, shaking. So for considering all these requirements, which is, let's say, A, B, C, or D even, will require a detailed nonlinear analysis. Then and then we can determine the desirable collapse mechanism. Here one more concept is added, which is called as the integrity, that it is desirable that the primary load resisting structural system provides the required integrity against undesirable structural performance. Under design earthquake shaking specified in this standard, if the stress resultant in one member or the stress resultant in a set of member exceeds the corresponding limit state of strength, the entire structure should not collapse either globally or locally. And the members of the structure should have the capacity to redistribute the load effects to the adjoining members. So therefore, a structure should possess a robust structural system having following. The structural system comprising of, let's say, spatial moment frames or spatial structure walls, floor and roof slabs that are capable of sustaining in-plane diaphragm action to transfer the forces between the vertical lateral load resisting elements. So there shall be redundancy in the system, then strength and local deformation capacity, connections between members designed to withstand the extreme load actions transmitted through them when the structures. So, general statements are made here with reference to integrity. Now, again, in this paragraph, desirable collapse mechanism is mentioned briefly. So, it says that the desirable collapse mechanism is a state of the structure in which all elements designed and detailed to behave in a ductile manner without any undue concentration of plastic rotational demand in any one member, and the absorption of ductile inelastic energy is high. So what it says that for each structure type there are limited possibilities of desirable collapse mechanisms. So the same should be identified before designing the members and connections. The one that absorbs the largest ductile inelastic energy should be considered in the design of the structure. So for this also, I believe detailed nonlinear analysis is required. Without this, uh, it is not possible, according to me, to identify the requirement of this paragraph. Then there is a requirement for the key elements. So key elements are members which, when they lost their strength during the action of strong earthquake shaking, it will result in disproportionately large damage to or even collapse of the structures. So those elements will be considered as key elements. So what is said here that we should be removing one member at a time from the structure to identify that which element is the key element, and then performing structural analysis of the residual structure. So first of all, removing one member at a time from the structure. After that, performing a structural analysis for the residual structure, and then examining the remaining structure for large damage or collapse under the applicable loads. And here it states that the method of analysis here should be nonlinear analysis, including both geometric and material non-linearities. So that's what my point will be here, that if it is required, then detailed procedure for non-linear, geometric and material analysis should be mentioned in the documents. And for that, the non-linear property of steel, concrete, etc. will be required uh, for entering into the software. And of course, there are many other sensitive parameters which needs to be defined in the standard, according to me, if this analysis are required. And these key elements should be designed and detailed to comply with the requirements of IS 13920 Part 1 and IS 13920 Part 2 to 10, which will be released in the future, depending on the type of the structure. Then attributes. The earthquake resistant design or earthquake resistant structure shall be designed to possess the following 5 attributes, but it is defined 3 here. The structural configuration that demonstrates direct, uninterrupted, and redundant load paths. Then members and connections proportion to have at least a minimum initial lateral stiffness, lateral strength, and lateral deformability, and large inelastic lateral energy absorption capacity associated with a predetermined desirable lateral collapse mechanism. Okay, so this each term needs to be understood. So again, in the next para, the earthquake resistant structural configuration is defined. That what are the general requirements. Then it talks about lateral stiffness, lateral strength, deformability and ductility, energy dissipation, and desirable collapse mechanism. We already touched upon this area. Then finally, design requirements. So for that, it specifies the stiffness requirement, strength requirement, and the deformability requirements. In IS 1893 Part 2 for buildings and in Part 3 to 10 for other structures, the requirements for earthquake resistant design and detailings are specified in 13920 Parts 1 to 10. So these are under formulation, as I understand. So whenever we adopt the site-specific spectra, so at that time the elastic acceleration spectrum, which is developed, let's say, for a design of structure, then the effects of the site-specific spectrum shall not be less than those arising out of the elastic acceleration spectrum, which is specified in this standard. So whatever elastic acceleration spectrum which is specified in this standard is minimum, even if we get the site-specific spectra requirements or demand as lower. The design earthquake force, okay, that's okay. Then strength design. So here it is a strength design. For the strength design, we will be having separate calculation of base shear, which is, let's say, EED, as it is mentioned here. And for serviceability check, it is denoted as EES. So firstly, we will get the values as per Z into I into acceleration, and thereafter we will be dividing this value by elastic maximum force coefficient for getting the value of base shear for the structure. So we'll have two calculation of earthquake forces. One is for strength and another is for the serviceability. And minimum design of earthquake forces are mentioned in, or rather it will be mentioned in all different parts, like from part number 2 to 10. And in any case, it is said that no structure shall be designed for earthquake force which is lesser than 0.015 W. So whenever the design effect, or in the load combinations, even if earthquake load combinations are not governing, in that case also the provisions shall be adopted related to earthquake resistant design and detailing relevant for earthquake conditions, so which are specified in 13920 and 13935. So even if earthquake load combinations are not critical, the ductile detailing needs to be followed. That's what it is mentioning here. For the load combinations, these are the load combinations, and here we can say this is the additional load combination, which is 1 times dead load, 1 times live load, plus overstrength factor into EED, where overstrength factor shall be taken as specified in part 2 for buildings and for part 3 to 10 for the other structures. So here I believe for this E, there may be some typing mistake for this load combination. As we'll see in the subsequent pages, it doesn't match with the other values. And for limit state of serviceability, this is new load combination added, which is date load plus 0.8 times live load plus EES. Okay. And then multi-directional earthquake shaking. Okay, so whenever we are considering two directions, so those kind of different scenarios are added. So firstly, it says that earthquake shaking along one horizontal plan direction at a time. So we can consider earthquake shaking along one horizontal plan direction at a time whenever the structural configuration plan is regular. And also the lateral load resisting system or elements are oriented along two mutually orthogonal horizontal directions in plan, which is in x and y directions, do not cause any stiffness eccentricity in plan. So in that case, we can consider the application of earthquake force or earthquake load in one horizontal plan direction considered at a time. In that case, the load combinations of earlier paragraph are replaced with this. So here we can see the last two load combinations wherein it is 1.2 times date load and live load is not there, and 1.2 factor is added for the date load. Okay. But likewise, load combinations are mentioned if seismic load is applied in one direction, and if the structural configuration is irregular in plan, so in that case we will consider earthquake forces in two directions. That is mentioned here as earthquake forces in two directions. So in one direction full earthquake force, and in the other direction it is 30%. So accordingly, load combinations are mentioned, and here we can see that this load combinations generally, as it was mentioned in the present standard also, that the vertical acceleration may be required for majority of the structure. So when vertical earthquake acceleration also needs to be considered, that means earthquake needs to be considered in all the three directions, then this will be the set of load combinations as it is mentioned here. Now for the earthquake analysis, the modeling criteria are given. So for the superstructure, it is okay. But for the soil, it says the flexibility of the soil stratum or strata on which the structure is rested, considering appropriately the level of water table, shall be addressed one of the two ways, namely. So there are two options given here. Considering just the flexibility of the soil adjoining the foundation structural elements in form of flexible soil translational or rotational springs. When performing the linear equivalent static analysis. So whenever we are performing linear equivalent static analysis, so at that time, we can consider the flexibility of the soil by inclusion or by considering the translational and rotational springs. And considering in the second part, it says in the second option, considering all aspects of soil structure interaction when required to perform the dynamic analysis with such effects considered for the structure being designed or accessed. So for the majority of the structure, we will have to perform dynamic analysis. That means we have to go with this second option, and this could lead to the practical difficulties according to me, and we'll see certain points in the subsequent clause. In the D, it says that the material properties of the structural elements of the structure, namely modulus of elasticity, Poisson ratio, and modulus of subgrade reaction K of the soil layers underneath the foundation shall reflect the range of the expected earthquake behavior. So the modulus of subgrade reaction, whatever we derive or whatever it is specified in the geotechnical investigation report, for that modulus of subgrade reaction, we need to consider range of the subgrade modulus reaction. So for soils, K shall be considered to vary over the range of 0.5 to 2.0 K, where K is the value of modulus of subgrade reaction estimated from field test. So here there could be practical difficulties according to me if you have to consider range of the modulus of subgrade reaction. The method of analysis is linear analysis, as it is mentioned, for the design of new structures, and linear analysis or non-linear analysis for the earthquake safety assessment of the existing structure. But as we were looking in the previous sections, it was mentioning general requirements for non-linear analysis. So this needs to be clarified, like in what cases non-linear analysis, which is mentioned in the earlier clauses, needs to be followed. And the linear analysis shall be performed by either of the two methods, linear equivalent static method and linear dynamic method. So linear equivalent static method can be followed only if, as it is mentioned in this standard, when the dominant response under earthquake shaking is governed largely, at least 80%, by the response of its first translational mode. So if we get the mass participation factor greater than 80% for the first translational mode of oscillation, in that case, we can consider this linear equivalent static method. So we can say generally, we may not be able to consider this method. So we'll get on this method, which is linear dynamic analysis method. And there are two options. One is the response spectrum method and another is the response history method. So response history is nothing but time history method. And response spectrum method also can be performed using the following process. So in this entire subsequent sections, it identifies the basic concept of response spectrum method. And then this is time history method. Okay. So time history can be performed actually by two methods. So one is the model response history method, as it is mentioned here, and then second is the matrix response history method. And this protection of minimum base shear force from the dynamic analysis, so it is nothing but scaling of the earthquake forces as it is done in the current standard. Then earthquake resistant design, the strength design for the structural elements in the superstructure, and for concrete and steel, it It's to be carried out by 456 and IS 800. Okay. And then structural elements in the foundation, the codes are identified here. Okay. Particularly here for soil in the foundation, what it says that the design earthquake force on foundation shall be taken as that corresponding to the larger of the following effects. So number one, design base shear VB of the superstructure when the superstructure is designed to remain elastic. Second, overstrength base shear on the superstructure when the superstructure is designed to undergo inelastic actions. Okay. So whenever nonlinear analysis is performed at that time, or let's say whenever this overstrength base shear is worked out, so in that case, the base shear needs to be worked out from this second paragraph. So for the foundation design also, two requirements are given. Okay. In addition to the provisions of 13920, part 1 and 10 shall be applicable to the respective structure. So over and above whatever is mentioned in this paragraph for the strength design, 13920 is always applicable. Factor of safety to be considered in the geotechnical design of soil. So here it defines the factor of safety which needs to be considered for geotechnical design. And we can see the factors are different for equivalent static analysis and linear dynamic method. Okay, finally it says the geotechnical aspects. So for the liquefaction, the methodology is added, which is estimation of cyclic stress ratio, estimation of cyclic resistant ratio CRR. And here we can see a number of formulas and methods are added, assessing liquefaction potential of a site. So here I have small difference of opinion. Like according to me, we should not include the geotechnical requirement in this design standard. Instead, I believe it should be included in the relevant geotechnical investigation standard, because the geotechnical engineers may not be referring to IS 1893, and I think it would be prudent. That's what my thinking is. Okay. Because structural engineer is not competent enough, to understand all these parameters. Now, for the soil properties, the basic input which is required is mentioned here. So what it says that if in a residential buildings up to 5 stories, corrected N values can be used. When shear wave velocity profiles are available, the same shall be preferred over the corrected N values. In all other structures, shear wave velocity value shall be determined based on the field test and used directly. So if our, let's say if we are working on the residential buildings up to 5 stories, then we can have corrected N values only. But for all other structures, we should have this shear wave velocity determined in the geotechnical investigation report as per this standard. Soil stiffness or the soil flexibility or flexibility of soil shall be considered in all cases except in the following cases. So whenever building is up to 5 stories height and resting on individual footings, and second, when structures are resting on sites of classes A and B, so which is, we can say, hard soil or a rocky type of soil. For all other cases, the flexibility of soil shall be considered as it is described here, which is translational spring as well as the rotational spring, which is defined here. Okay. And those coefficients or springs are defined for all different types of foundation, like individual footings, pile foundations, well foundations, etc. So it defines the the parameters which needs to be used for estimation of modulus of subgrade reaction for different foundation, as it is mentioned in this figure. Okay, this is soil strength. So here also I have same opinion that the sheer strength of soil, etc., it is better if it is reflected in the relevant geotechnical investigation standard. Even the bearing capacity calculation is also included here. The ultimate earthquake bearing capacity QUE of strip footing shall be taken as per this formula. Soil damping is mentioned here, which can be considered as a 2.5 percentage. But for assessment of structures under earthquake loading, it is required to use strain-dependent hysteretic damping instead of viscous damping when modeling the soil. And in the last part, it says it is talking about architectural elements and utilities. So for design of these architectural elements and utilities, it's a completely new concept which is introduced in this standard. So it will require substantial amount of additional effort, I would say, for whenever we are adopting this AEU. And we may have even different consultants who will be doing specifically design AEUs. We may have in future those uh, kind of specialized consultants also. So the AEUs are derived in three classification: acceleration sensitive, which are sensitive with from the acceleration, then deformation sensitive AEUs, and the AEUs which are sensitive from the acceleration as well as the deformation. And the table 7 identifies the categorization of common AEUs inside the structure, and then the sensitivity is identified, whether it is acceleration sensitive, displacement sensitive, or it is both. So why it is important to identify whether it is acceleration sensitive or displacement sensitive? Because based on that sensitivity, the applicable equations will be worked out, or design methodology will be worked out, which is specific to the sensitivity of this AEUs. Of course, we'll not discuss this concept in much detail, but during the subsequent sessions, if we require, we will discuss this area also. But you can refer this table wherein different components or different AEUs are listed, and then it is said whether it is falling under which category. And then in the subsequent pages, the design of different types of AEUs are mentioned, which is acceleration sensitive, displacement sensitive, and then acceleration cum displacement sensitive. So earthquake demand in AEUs, how to derive the earthquake demands, it is mentioned. Then acceleration sensitive AEUs. Now here we can see the equations are coming now. Similarly, of course, all different parameters are tabulated for different kinds of AEUs. Then displacement sensitive AEUs. For the displacement sensitive AEUs, it is said that, let's say, the AEU is, let's say, could be having three different conditions, that a structure at a different levels, second, adjacent structures at same level, and then adjacent structures at different levels. So these are the supporting conditions for AEUs, which is coming under displacement sensitive. How to work out earthquake demand, and after deriving that earthquake demand, how to perform the design, etc. It is mentioned. Okay, so that's all about this first part. So we can see that there are a number of additional or new concepts which are added in this standard. So you can go through this, and of course, if there are any specific points, we will still discuss it in further. Okay, so before we close the session, let's take up a few points here. Okay, Rakesh Kumar is telling, I feel all should stop. Good evening. Okay, and just put your valuable suggestions and questions so that questions are answered properly. Okay. Okay, AU means we have already discussed, it's an architectural and okay, AUs we have already discussed. Then yes, Akash is telling, for the better understanding of revision of the new seismic zoning map using PHA, can we have an expert or the committee member from IITM delivering a talk or discussing the issues regarding the applicability? Yeah, certainly we may plan if it is possible, but at this juncture, what we should do, whatever practical difficulties which we could envisage while implementing this design standard, if it is published as it is, that's what we should gather, and we should start sending those comments to BI's technical committee so that they can take appropriate actions within the stipulated time. Okay. Abhay Shodan is asking, what is the meaning of reverse time period? It is a life of the structure. I think you're talking about return time period, right? You can clarify your point in the next chat. Prakash is telling, like RCC building set 1-4, steel structure set 1-4, but some sets start from important structures or some set even start in the critical structures. Yeah, I also have exactly the same confusion while reading the different set of the structure. Okay, Dr. Barnali, course is telling these equations are dangerous, right? Yes, right. This actually there it increases the seismic force to a great extent with reference to the current standard. Jace is asking, can you please elaborate for which zone how much value of Z to be taken for return period of structures with simple example? What is the return period? So return period is actually the time period we are considering for the earthquake estimation. So as the return period increases, we will consider, or rather we can say that the probability of occurrence of higher intensity of earthquake will increase, right? So as you're asking about small worked out examples, so already few engineers have worked out those examples. So maybe in the next session or next to next session, we will demonstrate this with the simple examples. Okay, Dr. Barnali Ghosh is asking, are the spectra still not having long and short period anchoring? And one more point, deterministic hazard is the hazard when you have understanding of the hazards at the site, including the faults that may generate specific earthquakes. Okay. Okay. Yes, Pratmesh, if certain terms are not clear, please mention in the chat box. Okay, Rajnikant Parmar is telling here in written period table limit state of serviceability and strength, which were earlier liked by load factors for working and load factors load 1.5, 1.2, etc. are delinked using the written period. Yes, your understanding is absolutely right. Instead of applying the factors, now the that is controlled by the written period of the earthquake. Yes, Prakash is telling the details analysis should nonlinear when remove or collapse elements. Means research various papers like progressive collapse or nonlinear failure elements and detailed studies. Absolutely right. As it is mentioned in this document, each project could become a research project because it is required to perform nonlinear analysis. Now, there is not, I couldn't get very much clear understanding that in which cases it is compulsory to perform such kind of nonlinear analysis. I think that should be elaborated in this document. Okay, Ahmed is telling, great to know that many things are added which will contribute enhancing structure performance during earthquake. Certainly, there are many additional concepts which are added, which will enhance the performance of the structure during earthquake events. Akash is telling for nonlinear analysis, some equations, clauses for considering the stiffness of infill walls needs to be specified in this code. Yes, absolutely right. For nonlinear analysis, in fact, there should be a very detailed chapter. Otherwise, there are a number of sensitive parameters which could affect the output of the nonlinear analysis. Okay, Rajnikant Parmar is telling now number of analysis cases will increase exponentially to consider various soil behaviors and structure elastic and non-linear behavior. You're absolutely right. The number of models will increase, and still the stiffness modifier we have not included. So that is one more part, one more kind of analysis which we have to perform. Okay, and Rajnikant Pramar is telling methodology of soil investigation 2 will need great improvements to find stratified behavior parameters required for these analytical combinations. That's absolutely right. The soil investigation also needs to be updated, and along with these parameters, they also needs to find out shear wave velocity for a majority of these structures, and only based on that we can refer to the soil classification. And one more point, that minimum depth of soil exploration shall be 30 meter as per this standard. Okay, Professor Mayank Ghoshal is telling in page 22 TRP of 4995 is substituted by a TRP of 4975 in the subsequent page. Kindly explain. Okay, let me go through these pages and then I'll come back. Meanwhile, let's take a couple of more points. Steel design code and RC design code should also be updated regularly in order to reflect current provisions of earthquake codes. Yes, you're absolutely right, and that's what is getting planned according to me, as it is said that for IS 13920 all different parts are under formulation. So definitely certain part will be for the concrete structures and for the steel structures, etc. Okay, so thank you all for the participation. And of course, it is first session. In the second session, again, we will have a quick view about IS 1893 part part 2. And thereafter we will be taking up few about few specific points also, as we have received through the registration form. Okay. Okay, Ravi Kumar is telling, in my opinion, adding soil SPC calculation in this part will lead to more confusion. I perfectly agree with yourself that in this document, it's not only SPC calculation is added, there is also liquefaction criteria which is added. And also there are other several parts related to geotechnical conditions which are added. So of course that can definitely lead to more confusion. So I believe that this all geotechnical investigation related part, it should be included in the relevant geotechnical investigation Indian standard code instead of adding it into the Indian standard of code for the structural engineers. Yes, AEU is the architectural elements and utilities. So in essence, these are non-structural elements which are required for the performance of or for the functional requirement within the structure. So even during seismic excitation, the architectural elements and utilities, which is AEU, should be functional for important buildings like hospitals, schools, etc., as well as commercial complexes like stock exchanges, for example. Okay. But this is completely new concept, this AEU. So it will again require very detailed calculations, the understanding of structural dynamics, and then design of this AEU. And according to me, there will be a separate consultant who needs to be on board for design of this AEU for the project. Okay, so with this, we are coming towards end of this session. Okay, so I hope that at least you could have got some basic insight about this design standard, and at least I think you must have noted certain points which may be sent to BIS technical committee for their review. Okay. So I'll again request you that you please go through this standard and then please start sending your important and valuable comments to BIS technical committee within the stipulated timeline, so that appropriate actions can be taken and our design standards can be improved. Okay, so with this, we are closing this session now. And we'll be meeting soon. So for participating in the next session, you can follow us on the social media. So very soon we will be announcing the second session for IS 1893 part 2, as well as we have received many interesting points through the registration form. So those points also will be taken up. So while analyzing this document, I thought we must have number of sessions, because even in this document also you must have felt that there are a number of points or additional concepts which are added. In fact, each concept requires at least 2-3 hours of detailed discussion for getting into complete depth. But today we just tried to get it the overview of this document, so that quickly we can highlight the important areas. Okay, Rajnikant Paramar is telling we have just opened the Pandora box. Yeah. Okay. Okay, so with this, we are closing this session now, and we'll meet very soon in the next session related to IS 1893 part 2. Okay, so good night everyone, and we are closing this session.